Hey there and welcome. In this video, we're going to be talking about recursion in JavaScript. I'm going to start by describing what recursion is as a concept, why it's so important, and when it might be a good idea to use recursion. And then we're going to dive into some examples with code. Let's jump right in. All right, so what is recursion? Recursion is a programming technique where a function calls itself in order to solve a problem, as opposed to iterating or looping. There are two elements to a recursive function. First is the recursive case, which is the condition which, when it's met, it causes the function to call itself. And then there's the base case, which is the condition that causes the function to return and stop the recursive calls. So why is recursion important to understand? First of all, recursion can actually be more elegant and easy to follow than iterative approaches for some problems. And recursion can also be more efficient than iterative approaches in certain cases. So when is recursion used? So I think the most common use case for recursion is for problems that can be naturally divided into smaller and smaller subproblems that are similar to the original problem. You can also use recursion when dealing with certain data structures such as binary trees, linked lists, or graphs, where recursion can simplify traversal and searching algorithms. And also when working with recursive algorithms such as quicksort or merge sort, which are often faster and more efficient than the iterative counterparts. So let's jump into some simple examples that explain how recursion works. All right, let's go through a simple example of how recursion works. In this code, we're creating a function called factorial, which has one parameter n, and it's returning n factorial. Now, factorial means the product of all positive integers less than or equal to a given positive integer. So if the given integer is 3, what we want this to return is 3 times 2 times 1, or 6. Now, let's walk through this function code and try to imagine what's happening on the call stack. So the call stack is keeping track of all of the functions that are being called, as well as the local variables that are assigned to that function call. So first time we call factorial, it gets added to the stack. And in that case, n is equal to 3. And what that function call is returning is it's returning, so first it's checking, is n equal to 1, which it's not. So this line is not being run. Then it gets to return n times factorial of n minus 1. So this is returning 3 times factorial of 3 minus 1, or factorial of 2. Okay, so it's calling factorial of 2 now. So we add this on top of the stack. So now there's another factorial call. This time n is equal to 2. And then again, it's checking, is 2 equal to 1? No, so this isn't running. So then it returns, this time 2 times factorial of 2 minus 1, or factorial 1. So once again, we add another factorial call onto the stack. This time n is equal to 1. So now when this code runs, it checks, is n equal to 1? Well, this time it is. So this is going to just return 1. So you see how this is actually our base case, because this is stopping the recursion. Now this part is not going to run. So when 1 is returned, the stack essentially unwinds. So this is going to get popped off the stack, and it's going to return 1 for factorial with 1 as the argument. So if we can delete this, pops off the stack, and then this actually gets substituted for 1. So now that this has finished executing, this can now pop off the stack, and this time it's going to return 2 times 1. So we can delete this, and then this is going to become 2. So essentially, now this can pop off the stack, and it's going to return 3 times 2, or 6. All right, now let's delete all of this and just run this in DevTools just to make sure it's working. Paste this here, hit enter, and you see that it does in fact return 6. And if we try it with 4, well, what do we expect? 24, right? So 4 times 3 is 12, times 2 is 24, times 1 is 24. All right, now now let's take a look at a slightly more challenging example. In this example, we're going to take an array of integers called nums as an input, and we're going to return an array that contains all the odd values from nums. So we've created an outer function here called collectOdds, which takes nums as an input, and then within the scope of that function, we've created a variable called odds and assigned it to an empty array. And then we've created this helper function, which is actually the recursive function. You can see that helper calls itself here on line 11. Now, why did we do it this way? Well, if you think about it, if we take this odds value and we put it inside the helper function, this helper function, each time it calls itself, it's going to reset odds to an empty array. So we're not going to be able to collect the odd values in the array if we do it this way. So we've created this outer function and inner function to help us. So what's happening within this helper function? So helper is taking the input, which is going to be an array, and if the length of that array is 0, it's going to return. So this is the base case. This is the case that stops the recursion when it's met. And the first time it's called, this hopefully isn't going to be met if we are feeding it a proper input. So on this next line here, we're checking, is the 0 index element of helper input, so the first element in that array, modulo 2 not equal to 0. So modulo 2 is essentially dividing by 2 and then checking the remainder. So if the remainder, if you divide by 2 and the remainder was 0, that would be an even. So not being equal to 0, we know that this is an odd. So if it's an odd number, that first element of helper input, then we're going to push that element to the odds array. And then we're going to call helper again, so we're calling helper recursively within itself on a smaller input. And that smaller input is essentially the original helper input dot slice with 1 as the argument. So what this means is it is going to take a subarray and it's essentially going to slice off that first element, because this means start at index of 1 and then continue to the end of the array. So we're going to get the entire input less the very first element. And this is going to continue recursively. It's going to continue slicing smaller and smaller array until the array.length is 0, and then it's going to return. So then back to the outer function collectOdds, we're going to call helper on that nums value that gets passed in originally, and then we're going to finally return odds. All right, now let me just copy this and paste it into DevTools so we can make sure that it's working as expected. And you see here, 1, 3, 5, 9, and 23 is returned from this array. And those are indeed the odds. All right, let's wrap up with one last example. In this example, we're going to return the nth element in the Fibonacci sequence. And the Fibonacci sequence is a sequence in which you start with 0 and 1, and each number is the sum of the two preceding numbers. So I've listed out the first few in the Fibonacci sequence here. So 0 and 1 is to start, and then 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So we've got this recursive function here called fib, which takes a parameter n, and if n is less than or equal to 1, we return n. So this is a recursive case. So if n is 0 or if n is 1, we just return those values. Otherwise, we return these recursive calls to fib. So return fib of n minus 1 plus fib of n minus 2. So to try to understand what's going on in here, let's try to imagine what's happening on the call stack. So when we call fib of 3, first we add fib to the call stack, and n is equal to 3. And what does this return? So if we run through the code, if n is less than or equal to 1, return n. So is 3 less than or equal to 1? No, it's not. So we're going to return fib of n minus 1 plus fib of n minus 2. And if we substitute in 3 for n and simplify this to 2, substitute in 3 for n, simplify this to 1, now we have to call fib again with n equal to 2. So fib gets added to the stack, n equals 2. Once again, let's check, is the base condition met? It's not, so we have to return this. So return n minus 1 plus fib of n minus 2. So once again, plugging in 2 for n, this simplifies to 1, and then plugging in again, this simplifies to 0. So what is fib of 1? Well, we have to call it once again. So fib, n equals 1. This time, the base condition is met, so we just simply return n. So this is going to return 1. So this is done executing. We can pop this off the stack. So we know that fib of 1 is 1. So we can pop this off, and then we can sub in the 1 here. And now we have to call fib of 0. So we call fib again, n equals 0. And is n less than or equal to 1? Yes, it is. So we just return n. So return 0. This pops off the stack, and then this returns, evaluates to 0. And now this is finished executing as well. This is 1 plus 0, or 1. So we can return 1 from this fib of 2 call. And then once again, we have to call fib with 1. So fib gets added to the stack, n equals 1. And is 1 less than or equal to 1? Yes. So we return 1. So this pops off the stack when it's done, and then this becomes 1. And this finishes executing, and it returns 2. So let's just make sure that this works. Paste it here, then we're going to run it. So 3 returns 2, as expected. So the third element, or at the third index, I should say, 0, 1, 2, 3, is 2. At the 4th, 5th, 6th index, we should get the value 8. So let's try it again. This time we'll call fib with 6, and we get 8, as expected. All right, I hope you enjoyed this overview of recursion in JavaScript. If you found this video helpful, please be sure to hit like, subscribe, and I'll see you in the next video.